About inside and outside design conditions. Now let's go a little deeper, understanding where to get this information from, right? So, where do we find out what the weather is going to be like for Bakersfield, Tehachapi, Los Angeles, San Francisco, Santa Barbara, New York, Central Park, New York, Miami Beach, Florida? Where are we going to find out what the temperature trends are for those areas? Because those different areas affect homes differently, and they build homes differently in those areas. So all of that plays into designing the HVAC equipment. We're going to figure out where we're going to get this information from. We don't have to go very far. We can open up Google and type in ASHRAE climate design conditions. And ASHRAE, American Society of Heating, Refrigerating, and Air Conditioning Engineers, they collaborate, work together with weather stations, pull in the temperatures from different places around the world, and they form like a chart of trending information. They do a history, a log. They log all the information on the temperatures, the wind speed, the rain, precipitation, and they collect all that information in all these weather stations, and they put it on a chart for us to use to design an HVAC equipment. So I already have the Bakersfield selected here. And this weather station is located in Meadows Field, the airport. Now here's the chart we're going to use. We're not going to be looking at everything on this chart, so don't be overwhelmed. We're only going to look at basically two areas on this chart. So if you look right here, this is the annual heating, humidification, and ventilation design condition, temperatures, and percentages. So this is one section we're going to look at, really just this little box right here. And the annual cooling, dehumidification, and enthalpy design conditions. So the cooling design conditions. And this is the area we're going to be looking at for cooling. Now, if you notice here, there are percentages. You have 99.6 and 99%. That's almost 100%, but it's not quite. So what are these percentages mean? Well, let me explain these percentages this way. You have 365 days a year, 24 hours in a day, which works out to be roughly 8,700 hours in a year. So 99% of the time in winter, during the winter, or just 99% of the year, so only 1%, which is 88 hours, will it ever go below 36 degrees. So 99% of the time, it will always be warmer than 36 degrees. That's all that means. So, right? So 99.6% of the time, it will always be warmer than 33 degrees. So these are the numbers we can choose from when we want to design a heating unit. And what does this mean? That at 33 degrees, that's going to be our temperature difference that our heater is going to work against to put heat back in to the building at 33 degrees. Now, what about this other 0.4% of the time that it's colder, which is roughly 35 hours out of the year? So at 35 hours of the year, it's going to be colder than 33 degrees. And so, yes, our unit is sized for 33, but what about the other 35 hours where it's colder? So at that point, since we're spreading 35 hours throughout the winter season, 35 hours that's colder than 33 degrees, that is where our unit is going to keep working to heat the house, but it might not keep up. It might go a little colder than 70 degrees in the winter. It might go to 69 or 68. But it's not going to drop like dramatically or drastically because hopefully we have good insulation in the walls in the attic. Great double pane windows to keep the heat that we're putting in the home in the home. Nowadays with the energy standards that we use to build our homes, homes are able to hold heat in more or better in the wintertime. So these are the numbers they give us for designing a heating unit is 33 degrees or 36. So as a designer, you can choose between these two. And there's no right or wrong answer. It just depends on how you want to size that unit. So this is for the heating. We'll probably use this number here, 36 degrees, when we go back to our chart, our worksheet. For cooling, it gives us three different percentages, 0.4, 1%, and 2%. Again, what does this mean? So 0.4% is 35 hours in that season. It'll be hotter than 103 degrees. So we are really not looking for the hottest temperature, like 116 degrees in the year, and that's what we want to size a unit to, because we're going to oversize the unit, because how many hours does it really stay at 116 degrees? Maybe like 5, 10, 15 hours. We want to size it for a good portion of that high temperature, but not something that's going to be oversizing our equipment, causing high costs to run the unit, maintain it, build it, ductwork, and everything else. So these are the percentages that ASHRAE has given us that they recommend and that they've found to be the most energy efficient percentages to build that HVAC unit. So for us, we are probably going to use 0.4% because I know it gets hot over here and I want to keep my house nice and cool, even when it gets hotter than 103, which we know it does. So these are the two temperatures we're going to be looking at, 99% and 0.4%. So 36 and 103. So let's go back to our worksheet. Let's see, open up our worksheet. So for the winter time, we saw a temperature of 36 degrees. And in the summertime, we saw a temperature of 103. So if you work the math, this is where you're going to get your answers from. So you go 70 degrees minus 36 degrees, you get 34 degree temperature difference. So the heating temperature difference in the wintertime is 34 degrees. What about the summertime? What is the temperature difference in the summertime? So you insert 103 in your calculator minus the inside design temperature of 75 degrees. That gives you 28 degrees temperature difference. And that's how you determine your design conditions for the unit you're working on in your location. Remember, these outside design temperature conditions are for Bakersfield. If we look at, I believe I have New York on here, the design conditions are going to be different. So let's look at the design conditions for New York. Their coldest month is January. And guess what? The heating dry bulb temperature, 99% of the time, will not go below 17.3 degrees. Now, what if we did live in New York? 17 for winter. Let's look at summer over here. We're going to use 4%. So New York really doesn't get super high temperatures. They normally just see 90 degrees. Wow, that's crazy. That's not too bad, actually. So let's insert these numbers and see what that heating and cooling temperature difference looks like. So we have 17 and 90.7. So 17 degrees for the winter. And for summer, we saw 90 degrees. Wow. Okay, so let's work these numbers again. So 70 degrees minus 17 degrees is 53. So we'll enter 53 right here. So our heating temperature difference for the winter is going to be 53 degrees. So let's look at summer design conditions. So we go 90 degrees outside design conditions minus 75 equals 15 degrees. Wow. That's the temperature difference in the summertime, from inside the home to outside the home in the summertime. In the wintertime, the temperature difference between inside the home and outside the home is 53 degrees. Again, this is New York City, Central Park. So you could see that the emphasis is placed in New York City on heating equipment, right? In the summer, their cooling equipment, I would say in commercial establishments are important, but in residential, if you want, some good temperatures in your home, you would probably definitely have an HVAC unit on there. But you're only looking at 15 degrees with the outside temperature of 90 degrees. That's not too bad in the summer. I didn't know that that's all the heat that they get in the summer. But this is how we figure out design conditions right here. So you use your inside design temperatures of 70 degrees, our target temperature in the winter, 75 in the summer, to pull up your outside design temperature weather conditions. You have to use the ASHRAE climate design condition website, and that will give you your coldest month and the percentage of temperature for winter, and then your hottest month, it'll give you your cooling temperature for summer. So that is how you fill out the design conditions for the heat loss and gain worksheet. If you have any questions, make sure that you email me or ask me in class. I'll be covering the other sections in another video. We'll be covering Table A, heating, windows, and doors in one video. And in another video, we'll be covering Table B, cooling, windows, and doors. And in the final part, we'll go over how to fill out the whole construction data, calculating the heating U factors and BTU losses for the heating calculations, and also the cooling factors and BTU gain for cooling calculations. All right, everybody, you have a good night, and I'll see you later in class. Thank you.